So with that, my minor admonition, I'm delighted to introduce our next keynote speaker, Damir Bogdan. He's the CEO of QuantumBasel. Just to qualify, his talk is going to be how tomorrow's technologies will shape today's economy, the inception of a global quantum hub. So uptownBasel stands as a cutting-edge innovation campus dedicated to Industry 4.0. Damir is going to present the 4 foundational pillars of QuantumBasel, whose contributions to the strategic development of Switzerland's premier quantum computing and AI hub are noteworthy. So Damir, please come to the stage.
We heard a lot this morning about the challenges of quantum computing, and one really can say, listening to all that, somebody really has to dare to build up a hub for quantum computing because it might take a long time. On the other hand, we all know that we are not able to think exponentially. So the exponential thinking is not something which we humans tend to do so. So the question is how long it takes until quantum computer is here, and this is how I want to kick off my next 20 minutes. This is uptownBasel. This is an innovation campus in Basel, obviously. This is an animation, so not all the buildings are finished yet. They will be finished by the end of this decade. You see Basel in the background with the Roche Tower, France to the left and Germany to the right. And within this campus, 1.5 years ago, we decided to build up a hub for quantum computing and AI. And our vision is to democratize the access to quantum computers, and our mission is to make it as easy as possible. And I can tell you, it's not that easy, because when you start thinking about quantum computing, as I mentioned at the beginning, it is perhaps not here yet. So I want to showcase you why versus why not mindset, how we did it, and what are our offerings or services. And this is our private investor, Dr. Monique Staehelin, who put 550 million US dollars or 500 million Swiss francs of his private fortune into the development of this innovation campus. Now, we heard before that sometimes Basma Abrahami said that we need more governmental backups. Yes, this would be great, but we started with this private investment, and I can tell you, we started in an environment, and this is perhaps our vision, how it will look like. No, we started in an environment where everybody says, why should you do so? And this why is something which we people tend to ask ourselves when we hear somebody coming with a great idea. And what I want to refer to Silicon Valley is that there we've got this why not mindset. And Thomas has exactly this why not mindset. Why not investing in quantum computing? We think this could be something. So it is important to have this kind of mindset. And it is especially important to have this kind of mindset when you look at the trend radars and you look at what technology will become when accessible. And quantum computing, back then when we started, was perhaps 5 years or 10 years in the future before you can have real access. And so it's hard then to say, okay, let's put our money, our private money in this, but overall we did it. And when you look a little bit back as well, the speed of change never has been as fast as it is today. At the same time, it will never be as slow as today. And we see this when you look back a little bit. So when the analog world developed, it was a flat curve. Then the digital world started to kick in, which was already a little bit steeper, and then hyperdigitalization kicked in over the last decade with quantum computing, natural language processing, and everything like that. However, and this is something important from our investors' perspective as well, we are hitting a kind of a barrier. And the barrier is our planet. And sustainability or regenerative is very important for the family Staehelin. And they see that with everything we are doing, we could contribute a little bit in towards a better future. And so we already heard from Saudi Aramco this morning a few parts where quantum computing could contribute, be it in the CO2 reduction or with new kind of materials. But this is something we are also looking forward to. And so to conclude this why versus why not mindset, if you look at sustainability, technology comes help sustainability, and sustainability again helps technology partners. We see that because I will introduce you now to QuantumBasel a little bit more, but we've got our data center, and we see that data center providers want to come to our campus because we've got everything there. We've got the energy, plus we heat about 3,000 apartments around of the usage of this energy already in our data centers. And so this is our goals, and this is the interaction between technology and sustainability. And just one example is the Haber-Bosch process, which you all know. This is this is here to make ammoniac, so the fertilizers in the world for industrial agriculture are all done with the Haber-Bosch principle. But however, the Haber-Bosch principle is responsible for 1.8% of the worldwide CO2 pollution. So if one could once perfectize this process, optimize it, then perhaps we can even reduce this worldwide CO2 pollution just with this one process. I do know this is not around the corner. I don't know if it's in 10 years around the corner, but what I do know is that quantum computers are exactly going into this direction. So this is a little bit the overall entry point where I want to say this is the mindset, these are the goals, this is the vision we've got at QuantumBasel. And on the other side, we also know that AI is taking in a lot. So with artificial intelligence, we try to solve all the problems we already have today. And we've learned that it is from Jean-Pascal from BCG before, that it's hard to compete against classical computers, as quantum computers not yet can be better in many cases. But so we are beating as well with AI. But AI comes also with some problems, because there are technical limitations with artificial intelligence. And the one is that it really needs high computational resources. And if you talk about robustness and generalization, so you see there's not only just with quantum computer where we have to talk about robustness, then these AI models struggle to generate from their training environment. So if you really want to do this learning on the fly for an AI, you need more and more classical computing power. And classical computing power is, unfortunately, again, a huge environmental impact. So before ChatGPT moment hit in 1.5 years ago, the worldwide energy consumption for data centers tended to be at 8%. It already raised now over the last 1.5 years to 13%. And in some countries like Ireland, it's about 17%. So this percentage may vary a little bit depending on the source, but however, if you want to solve all these problems we are facing, not just the environmental ones, if you want to solve this with classical computers, if you want to solve this with AI, then you are going into a next challenge, and this is our energy consumption. And this is, again, something we are hoping that quantum computer will make a change. And on the other side, AI and quantum computing are perfectly symbiosis, because with AI you can develop more accurate, better quantum computers, so where you can help to develop it, and on the other side, better quantum computers can again a little bit power on AI solutions. So you see, it's a symbiosis. And this is why we said that our hub will be present in both worlds. So on the left side, we will have the quantum world, and on the right side, we have the AI world. And what we are doing, we are helping industry partners to conduct projects with ours, and we help them to train how to use quantum computers. For that, we have 4 industries: logistics, financial services, life science, and industrial production, as we see that they are those industries which are perhaps not life science immediately, but the other one, we can have use cases already. So what we did, we signed contract with IBM. So this is our partner where we became one of the global innovation quantum hub partners. And we see the same with a D-Wave. So we've got a superconductor and an annealer. And not even a year ago, we signed a contract with IonQ, which was mentioned in the morning as well. And there we acquired a physical system, which is at the moment in the make at our campus. And with this physical system, IonQ is opening up its EMEA headquarters, so it will be responsible for this region as well at ours, and D-Wave is opening up its European offices at our campus as well. So we've got the hardware. On the other side, we also have hardware and partners with NVIDIA, because we see that GPUs are needed, and I will tell you a little bit later what we are doing with these GPUs. So if you've got the hardware access, this is one thing. But then you need also clever software solutions, and this is why we are ramping up our accelerator system. So Kai Venture, with the representative Alexandra Beckstein, who's the CEO, she's here as well. She will be in a panel in the afternoon. She built up Kai Ventures. This is an accelerator for quantum and AI startup funded with 50 million Swiss francs. And there we want to attract quantum startups to come with clever solutions to our campus so that we can develop together with them, with our industry partners projects. And we've got other partners there as well. We have close collaborations with different kind of companies, but also with different kind of countries. And on the other hand, we heard about the importance of having our future talents. So we've got close interaction and partnership with many academia. This is a list of few of them. So clear, University of Basel, but also Weizmann Institute in Tel Aviv, NZCR Spin, where they are researching on spin qubits. And we are also financing a chair for quantum computing, a professorship at the University of Applied Life Science. We provide our technology access to university partners in order that their students can use this technology and to learn. And once they've learned, perhaps they will start thinking, they will make a startup, and once they founded a startup, we've got the accelerator again, which can help them to scale up, and then we will start to collaborate with the industry partners. And this is how we do it. So after 1.5 years already, we've got quite a traction. When we kick off a project, and usually some famous newspapers and news from Forbes magazine and Financial Times are discussing about it. And for us, being in Switzerland, we are very proud to have done it between ETH and EPFL, also on the list of the quantum ecosystem within Switzerland. But as I said, we are not just serving Switzerland. Our people here at QuantumBasel are publishing quite some papers, and we heard it this morning. Ethical discussions are also important. So Frederick Flöter, our head of quantum, just published why business adoption of quantum and AI technology must be ethical. We see this is something we have to think about. So what are we doing? As we know that quantum computers are able to tackle 3 things. First of all, optimization. Second one is simulation, and the third one is machine learning. So we try to adapt these 3 problem types to application, and then to see in which of our industry we could deliver use cases with. And we also have our own AI-enabled platform, our QPilot, and our QPilot helps one to write algorithms. And the beauty of it is, it is already about half the time saved due to the AI who learned all the algorithms needed to program an IBM computer or a D-Wave machine or an IonQ system. And the second beauty is once the code is developed, it can be easily transferred from one computer to the other. So it can be reused no matter the quantum computers. So this is something which we are helping with the help of AI. We generated our own platform which then runs overall. And I told you about 4 industries, so I will showcase a few examples out of 3 industries. So this is financial services. So we divided financial services in what kind of problem types are there, where can we use optimization, simulation, or machine learning. And so these cases aren't cases from ours. These cases are use cases which have been conducted from our partners, be it IBM, D-Wave, or IonQ, but they are a lot. And one of them also started in 2020, MasterCard. It was about fraud detection, and they started with AI, with a fraud detection platform, so to look how many losses can be prevented with AI, where you can recognize that MasterCard is perhaps wrongly used up. However, this year, MasterCard announced that they will now start thinking about the same problems already with quantum computing. So this is how we see that technology is developing. So they're thinking now how D-Wave, in this case, could support them with the same task that they did so far with AI. So overall, what we see near-term use cases within the financial services industry is pricing, risk calculation. Monte Carlo is not there yet. And if you compare a Monte Carlo simulation with 10,000 parameters, then you always have to take a classical computer. But once you run it perhaps with 1 million parameters, and once the quantum computers are fault tolerant, then we can quadruple the speed, or you can really have better results. So this is just about Monte Carlo, machine learning, and encryption. I don't go deep into encryption for sure, but we all knew Y2Q is coming. We just do not know when this will be the case. So the second industry is industrial production. Same pattern. Here we conducted last year a project with quantum computers, with Vinci Energy, and it was about the optimization of HVAC. So in complex industry buildings, you have all these pipe and on the roof. And we started to simulate this before the company started to build the factory. And after 9 months, we conducted this. It's publicly known, so you can Google that. And the results are really unbelievable. There are crossings, and we had a lot less crossings on these pipes, and this means less energy has to be for the airflow. Then there is less material used for the simulation, and the simulation was really speed up. I can't tell you exactly the percentage, but I know them, but I'm not allowed to share them. But this is just one example, and now we are planning to take this into production so that worldwide about 30 factories already this year will be planned with quantum computer, only these systems. And one can imagine HVAC was just one thing. There are many other routing problems which can be used in complex manufacturing facilities. Again, here, near-term use cases we see over our partners we can conduct together is, Hyundai is working on next generation of batteries, industrial building, and you can read it on your own, and again, quantum safe encryption. The last part is logistics. I don't want to step into this. Petra from IBM already mentioned their partnership they are doing with Boeing. There are other airline and other famous examples. So you can Google LA port and quantum computing. You will see how the port of LA made a project with quantum computing. So what we do, and this is my last part, so what we do exactly is we explain how quantum computer works. I just had a meeting yesterday night with the Swiss Banking Association, and so we try to wake up a little bit those kind of associations, but also the kind of industry partners to tell them, hey, perhaps it will happen in a couple of years, but you should start now. because waiting until it's here might be too late. As Boston Consulting Group pointed out in their last year, they said 90% of the market value will be taken by those who are in the market now already. So we help them to learn these foundations. This is on a short term. We train the managers to do so, and we develop quantum strategy for corporates within this field. And at the end, then we can secure and update this and look how the quantum champions can be built up within a company. It has also been mentioned this morning that it is important, if you want to start a quantum project, you really need a quantum champion within the company as such. This is something we are going to. So I will skip this slide. It's very busy. You can Google this online. But we've got, as I said, three different kind of quantum hardware suppliers. We've got the whole ecosystem. We've got collaboration, global collaboration, and we've got the seamless multi-hardware platform. So coming back to our mission to make quantum computing as accessible, as easy as possible, this is what we are doing. And, well, I've spent a little bit too much time in Silicon Valley, as one can see. So there is always one more thing. And so this one more thing is not something about technology, but it is something about learning. And I want to invite you to our Global Quantum Symposium, which will take mid-March in Basel. We will have 3 days where professors from the whole world, from 15 countries, from Japan, Australia, UK, Holland, US, will be kicking off, and they will talking about the latest research in quantum computing. We will have 20 industry partners from US Air Force, from BBVA, HSBC, Erste. We will have industry partners like Vinci talking about how they already did quantum computing use cases. We have ecosystems. Charles DeHaan is coming from the White House in Washington. He's responsible for the US program. We've got Jerry Chow from IBM as a chief scientist, and so on and so on. So I would like you to invite you, come to Basel. This will happen soon, and you will learn more. And this is already a fabulous conference, so I did not want to make any marketing before this one, but now we are here already, so you can think ahead to the next one. And with this, I'm done, and the clock is on 000, and this is my LinkedIn profile. As you said, try to engage. Thank you very much for your attendance.